Hi guys, welcome back to the channel. And in this video we are going to see how to do the obstacle avoidance using turtlebot simulation versions. So in this video you will understand how we can develop the node which is going to do the obstacle avoidance using a scan topic from the LiDAR information. So and it will be share the twist message to the CMD well, and it will do the wheel control from the LiDAR information. So you can implement this same node, same code to your hardware robot, and you are going to get the scan data from the LiDAR, and you are going to do the obstacle avoidance from the safe distance range like that. So like ultrasonic, how it's working, like that we are going to do. So we'll start the video. So first we need to create a package. I already created a package. Inside the package we need to create a node as an turtle turtlebot finding free path dot py. So this is a node. So in this node, first every time we need to import the essential libraries. I'm using a RCL Pi is a library for in ROS Python client API. So then we initialize the node library. Then we import the sensors message type. So this is for the LaserScan. So then we import the twist message for the CMD velocity command sending. So then we do the function. So that we create a node, obstacle avoidance nodes, a name, initializing a name. Then we subscribe the node to the topic of scan. So from the LiDAR we are subscribing this node to the scan topic. So it will receive the scan information from the LiDAR. So this is a subscriber topic, and it will receiving the data from the LiDAR scan. So then we publishing the information to the twist in the twist command, twist type message from the laser scan to the twist message in the velocity form to the CMD well. So CMD well is going to be a subscriber from this node. So this node is going to be a publisher, and the CMD well, the wheel is going to be a subscriber. So from the laser scan message, we are sharing this LaserScan message to the twist message to the wheels to control in the obstacle avoidance part. So then we initializing the safe distance is the 0.5 meters. So if obstacle is near to the 0.5 meter, less than or greater, it will do the obstacle avoidance. Less than means it do the obstacle, else it will go in the straight path, and if it's find out the safest path, it will find the easiest route. Otherwise it will detect and it try to move in a different path. So that it will be do by this safe distance 0.5 meters. Then LiDAR callback function. So here we'll use a function statement. So the range, the minimum distance we range already indicate here the safe distance, right? So then after we using a twist message to if else function, the function statement we imported. So the minimum distance we already mentioned in the top, right, the 0.5. So here if the obstacle is near to the robot, so it will reduce the linear axis to the 0 and do the angular twist from 0.5 in angular wise. So else there is no obstacles, it will move in forward, there is no the angular twist. So there is any obstacle, it will do the twist, angular twist. There is no obstacle, it will do the linear twist. So that's the thing. Then we initializing node and doing the keyboard interrupting part and things the shutdown the things part. So this is a sequence of steps. I already wrote a Medium blog on this. You can find it from my description. Right. So we'll launch and see what's the output we are getting. So first we need to import the essential library. Then we initializing the node and the subscriber publisher thing. So here it's subscribed to the scan topic, and it's publishing the CMDL to the wheels. So then after we are giving the function statement like less than or equal. So the minimum distance, safe distance, we give the 0.5. The obstacle is near 0.5, it will do the obstacle avoidance, else it will move on forward. It detect the obstacle, it will do the linear angular twist. If there is no obstacle, it will do the linear. Okay, that's the code is explaining thing. So the code is working part. Okay, so then escape from this and make a Qualcomm build. So after making Qualcomm build, we need to source our workspace, and we need to find the scan topic, it's working or not. We need to find that. So types ROS2 topic list. Okay, ROS2 topic list. Wait for some time. Let me say neutral. Yeah, here you can see CMD well is available and the scan topic is available, right? So now we'll launch ROS2, run, open, object tracking, and turtle boat 3 free path. Okay, we'll enter and go to the point. So the robot will start moving forward, I guess. Yeah, the turtle is moving forward. So there is no obstacle, so it is going in forward motion now. So if we add a obstacle, it will stop and it will change to the twist. Now it is in linear twist. So if we add obstacles, it will go into the angular twist. So we can find out that. Yeah, you can see that. So now it changed to the linear to angular twist. So if I remove this obstacle from the area, so it will go to the linear twist now. Okay, so now I am going to add a obstacle to the robot, to the turtle. So you can see now linear to the angular twist, it will change. Now it will rotate, it will start rotate. Well, it reaches 0.5, the safety distance, it will start rotate, the twist, angular twist. So I am going to remove this now. So now it will start a linear twist. So once again I will add obstacles, so it will start an angular twist. So I am removing, it start a linear. So we'll add another obstacle to the robot and it will start rotating. So then after we can implement other thing like the PID tuning for doing the finding the shortest path and the algorithm, path planning algorithm A star, these things we can implement on this. So this is like working like an ultrasonic sensor with the point, and it will detect the obstacles and it will move on. So these things is working on. So we'll open RQT and we'll see how it's going. RQT. You can see that here that LaserScan, the node which is receiving the laser message to the scan is sharing the information to the object avoidance node, and the object avoidance node share the computing process to the CMD world to control the turtlebot driver. So this is going to be a publisher, the LaserScan, the LIDAR is going to be a publisher using the topic of a scan. The object avoidance is going to be a subscriber. So here it changed to the publisher and your wheels is going to be a subscriber by using a CMD word. So like this is working. So you can implement it with a real robot also this. So well, obstacle avoidance, if the robot is near to the object, so it will stop and it change from linear to the angular twist and it will move on. So if the robot is in free space, it will move in a linear space. So like that you can code and do it basics projects and basic understanding of a ROS. Thank you. We'll see in next video with an ROS2 with the A. Thank you. Subscribe the channel.